Well, we are now starting lesson 7B. It's after spring break. We're going to kind of touch base just a little bit on what we did the last time our class met before spring break. We had done 7A. We did a little warm-up. This is the exact warm-up that we did. We're just going to kind of talk about it a little bit. How many different choices of car does a person have if a particular model comes in 11 colors and 5 styles? This is all about probability. There would be 11 choices on the color, 5 on the style. You'd multiply those two together. You'd have 55 choices. Number 2, use the theoretical model to determine the probability of the next president of the United States to be born on a Sunday. There are 7 days in a week. Sunday is one of those. 1 out of 7. Number 3, you can order a new car with a choice of 16 colors, with or without AC, with or without power windows, with or without CD. And how many different ways can a new car be ordered? Multiply these numbers together. You'll get 128. There's 128 choices. Number 4, the probability that Cal 2 students will pass a test is 41%. What's the probability that they will fail? 1 minus 41 equals 59. 59%. That should make logical sense. Now, that just kind of got us back into the idea of we're talking about probability in this chapter. Kind of make you do a little thinking. I hope that you have gone to your email, printed off the handouts that I've sent. I've sent you the handout and the key for lesson 7B. So you have both of these in front of you. We will be referring to this. It's the printout of a standard deck of cards. Notice over on the left side it's got black, black, red, red. We will also be referring to this sum of 2 dice that is on the handout from 7A. We will be counting up how many of these there are all together and referring to this. So be sure you have those things handy. If you don't, then just hunt them up, print this stuff out, get back started when you got it all together so you know what you're doing. 7B, and probabilities. Dependent and independent events. Independent. The outcome of one does not affect the probability of the other. In order to find that probability, you multiply the probability of the first times the probability of the second. Dependent. The outcome of one affects the probability of the other. So when you do probability of A and B and it's dependent, you do the probability of A times the probability of B given A. Directions. Sum a standard deck of playing cards. Determine the probability of each of the following with replacement and without replacement. Write your answer as a fraction. So with replacement is independent. Without replacement is dependent. I think after we look at a couple of these, you'll understand a little better. What's the probability that you're going to draw a 4 and put it back in the deck of cards and then draw a king? Well, there are 4 4s in that deck of cards. There are 4 kings in that deck of cards. You got 1 chance out of 4. 4 chances out of 52 to draw a 4. the same probability to draw a king. When you multiply these two numbers, you're going to get 1 out of 169. Now, what if you draw that 4 and you lay it over here and you don't put it back in there? You had 4 chances out of 52 to get that 4. Now then, you've got 4 chances out of 51 to get that king, because if you get that 4 and you lay it down over here, you don't have 52 cards in there anymore, you got 51. Multiply straight across, 4 out of 663. Number 2, what's the probability you're going to get a red and put it back in there and get another red? 26 out of 52 times 26 out of 52 is 1/4. What's the probability you're going to get a red? You're going to hold it out and lay it over here. Now then, how many red cards are in that deck of cards? There's not 26 anymore. There are now 25. How many total cards are in there? 51. Multiply straight across. Simplify. 25 over 102. Let's skip down here. Let's do what's the probability you're going to get a red and then a black? 26 out of 52. Put it back in there. 26 out of 52. 1 out of 4. What's the probability you draw a red one? You hold it out and you don't put it back in there. Well, now then, there's just 51 cards in there, but how many of them are black? Still 26, because the first one you drew out was red, so this is 13 out of 51. These just require you to do a little thinking. Let's look at the next page of this. Identify each of the following as dependent or independent, then determine the probability. Randomly selecting a 4-person committee consisting entirely of men from a pool of 10 men and 8 women. There are 10 men and 8 women. What is the probability of drawing all men? The first time I draw, there are 10 men out of 18 people. The second time I draw, I'm not putting that man back in there. I already got him. So I just have 17 people. Only 9 of them are men. The third time I draw, I have 16 people to choose from. Only 8 of them are men. And the fourth time I draw, I just have 15 people, and only 7 of them are men. Multiply straight across. They want you to change this one to a decimal, round it to 4 decimal places. Multiply straight across, and divide. Get your answer. Number 2, rolling 5 twos, rolling 2s on 5 rolls of 1 dice. Well, whenever I roll that first dice, I've got 1 chance out of 6 to get a 2. When I roll it again, I got 1 chance out of 6. When I roll it again, I got 1 chance out of 6, and 1 chance out of 6, and 1 chance out of 6, which is 1/7776, which is approximately 0.000129. Number 3, similar to what we did on the other page. Let's look at number 2 down here on the bottom. Identify each of the following as dependent or independent, and then determine the probability. Drawing a 4 and then a 7 with replacement. With replacement tells you it's independent. The probability of drawing a 4 is 4 out of 52. If I replace, I still have 52. 4 of those are 7s. That gives me 1 over 169. Let's look at number 3. Number 3 is without replacement. What's the probability that I will draw a king and then a queen? 4 out of 52, and then 4 out of 51, which is 4 out of 663. Maybe this will give you a little idea of how these probabilities of dependent and independent are working. Remember, you got the key that's got every answer written on them, so we're only just looking at a couple of them.